Okay, so here I have the three possible types of triangles. We have our acute triangle, no angle is greater than 90 degrees. Here we have our right triangle with one angle exactly 90 degrees, and then we have the obtuse triangle with at least one angle greater than 90 degrees. Now, in each of these, what I'm going to do is I'm going to show that the area is your base times your height, or this altitude, right? Base times your altitude or height, same word, altitude and height, it's just this line. And so how are we going to do this? So let's start going through this. So the first thing is that I'm going to look at this triangle. I'm going to call this triangle ABC right here. And I'm just going to say that I can duplicate this triangle, right? I can duplicate it and I can rotate it. So that way what happens is that I can place it right here. So again, this is the same triangle as ABC, but I rotated it so the right angle's up here. This side length, right, is up here. And then this side length is over here. Now, I've already made it that they're congruent. I don't need to prove that they're congruent. But I do want to show that this here, this whole angle, and I'm going to make it clear that this whole angle is actually 90 degrees. I want to show that fact. So what I have here is if this is angle 1 and then this is angle 2, we should convince ourselves that in this corner over here is angle 2 and then this is angle 1. What I want to show is that angle 1, the measure of angle 1 plus the measure of angle 2 is 90. Because then that guarantees that this is a right angle. And that's something that I really want to guarantee. I want to guarantee that that's a right angle. So, well, that's easy because over here, just this part, right? Just the bottom part, just this angle 2 plus angle 1 plus this 90 degrees has to equal 180. But then that forces that 1 plus 2 has to be 90. And then that guarantees that this is a 90 degree angle and this is a 90 degree angle. And once you have that, you know that this is indeed a rectangle. This piece right here is a rectangle. Because everywhere is 90 degree angles and it's four-sided, so therefore it's a rectangle. Now, the thing is that we could come up with a relationship within this rectangle as well. We can say something. We can say that this triangle right here, right, it has some area. So let's say that's the area of the right triangle. Or area of, I don't know, triangle 1. Because I don't want to say right triangle. Because even though it's on the right side, I don't want to confuse it with right angle. Right? So area of triangle 1 times 2, right, is going to be equal to the area of rectangle, right, of rectangle. I'm going to call it rectangle ABCD. Rectangle ABCD. And that's obvious because what did I do here? Well, I just took this triangle, I duplicated it, and I flipped it around a little bit, and I placed it right over here. Okay? So we should see that fact. Okay? Now, I can make a similar argument with the triangle ABCDE. So I can make a similar argument with the triangle ABE, right? Everybody sees this triangle right here. It's a right triangle as well, and I could duplicate it, flip it around. If I call this angle 3 and then this angle 4, and I flip it around, I'm going to get something that looks like this. And then this is going to be 4, and then this is going to be 3. And we should, again, be able to convince ourselves that 3 plus 4 is 90, because 3 plus 4 plus the right angle is 180. That forces measure of 3 plus measure of 4 to being 90. So this is a 90 degree angle. And again, I have a rectangle here. So let's write that relationship. So this blue one, this blue triangle, and let's call this light blue triangle triangle 2, right? So 2 times the area of triangle 2 is equal to the area of the other rectangle, right? Because I put two of them, so we should see that the pink triangle is the same area as that light blue one because it's the same triangle. So I should see that twice this blue area is going to be this rectangle's area, right? So area of rectangle ABEF, let's say ABEF. And we should convince ourselves of these things. The last thing that we have is we need to just look at what we care about. Well, what do we know? We know that the area of the entire rectangle, right? We started off with certain dimensions. We started off with this length, right? This is called, we're going to call this the base. And then we were talking about this length. We're going to call this the height. Okay, so this is H. And what we should convince ourselves of is that the area of the entire rectangle, right? Area of the entire rectangle. Area of rectangle FDCE is equal to the base times the height, right? Because this length, again, is B, the base, and then this length is H, the height. Now, what also is this equal to? Well, this is equal to, we should convince ourselves that this is going to be the same thing as this rectangle, this red rectangle on the left, plus the red rectangle on the right. And what is that? Well, the area of the one rectangle is this, and then the area of the other one is this, right? The sum of these two areas, this area plus this area, is the area of the entire rectangle. And from here, it's just sort of algebra. So I have area of rectangle, I'm not going to write it, BABCD, plus the area of ABEF is equal to the area of the entire thing, which is equal to B times H. Now, to finish this one, what you say is you substitute in, you have 2 times the area of triangle 1 is the same thing as this one. So instead of writing this, I'm going to write 2 times the area of triangle 1 plus 2 times, so I substituted this, right, for this. Now I'm going to substitute this with this. So 2 times the area of triangle 2 is equal to base times height. And then there's a 2 in both of these terms. So by algebra, I could factor out that 2 and I get the area of triangle 1 plus the area of triangle 2. And again, this is all equal to base times height. The final step is that we should see that the area of triangle 1, of course, the area of triangle 1 plus the area of triangle 2, that's this, right? This is the area of triangle 2, this is the area of triangle 1, right? The sum of these areas is the area of the entire triangle. So this is 2 times the area of triangle, the original triangle that I drew. So it's 2 times area of triangle. The original triangle was triangle AEC. AEC is again equal to base times height. And that's 2 times the area. So you divide by 2 and you get your area of triangle AEC is equal to base times height divided by 2. And these other cases are similar arguments. You just duplicate this triangle one more time, right? And you can make the same argument. You could say that the area of the rectangle is base times height. And you make a similar argument with this one, you just draw the same picture, and it's the same thing for all three cases here.